Saturn is not the beautiful, serene giant you think it is. From a distance, those rings look delicate, almost peaceful, a postcard from the outer solar system. But get closer and the picture changes entirely. Saturn is a world where storms have been raging for centuries without pause, where the wind reaches up to 1,800 kilometers per hour, the second fastest of any planet in the solar system, surpassed only by Neptune. Where a hexagonal jet stream, roughly the width of 2 Earths, has been locked around the North Pole since NASA's Voyager spacecraft first photographed it in 1980, and no one can fully explain why it is a hexagon. Saturn is not peaceful. It is the solar system's most sophisticated machinery of destruction, and by the end of this video, you will never look at those rings the same way again. The only question is why it took us this long to look properly. For most of human history, Saturn was the edge of the known solar system. Ancient astronomers called it the slowest of the wandering stars, a point of pale gold light that crept so patiently across the sky that it took 29 years to complete a single orbit. A child born the year Cassini launched would be finishing university before Saturn had made it even halfway around the Sun. To the Babylonians and the Greeks, it was associated with time, with age, with the outer boundary of the cosmos. When Galileo first pointed a telescope at it in 1610, he saw something strange, what looked like 2 smaller bodies flanking the planet on either side. He could not resolve them. He did not understand what he was seeing. It took another 45 years until Christian Huygens built a better telescope for anyone to recognize the truth. Saturn was surrounded by a ring, a single, continuous ring, smooth and flat and impossibly thin. That image, the lone ringed planet, elegant and isolated at the edge of the solar system, became one of the most recognizable pictures in the history of science. It was also misleading, because Saturn is not a postcard, it is a warning. In 2004, NASA's Cassini spacecraft entered Saturn's orbit after a 7-year journey across the solar system. Over the next 13 years, until it was deliberately destroyed in 2017, it sent back data that dismantled nearly everything we thought we understood about the planet. The first shock was the atmosphere. We knew Saturn had storms. What we did not know was their scale. Before Cassini, the expectation was that Saturn's atmosphere would behave like a quieter version of Jupiter's, large but predictable, seasonal, contained. That expectation did not survive December 2010. The Great White Spot, a storm that erupts periodically in Saturn's northern hemisphere, expanded to encircle the entire planet within 6 months. Its lightning bolts were 10,000 times more powerful than anything ever recorded on Earth. Scientists monitoring it described the radio emissions as so intense they initially suspected an instrument malfunction. Linda Spilker, Cassini's project scientist, said simply, "Saturn kept surprising us. Every time we thought we understood something, the planet showed us we didn't." But the storms were not the most unsettling part. The most unsettling part was what Cassini found beneath them. At Saturn's North Pole sits a structure that has no equivalent anywhere else in the solar system. A persistent hexagonal jet stream approximately 32,000 kilometers wide, roughly twice the diameter of Earth, with an area large enough to contain 4 Earths placed across it, with a massive rotating storm at its center. It was first detected by the Voyager spacecraft in 1980 to 1981. When Cassini arrived more than 20 years later, it was still there, unchanged, still hexagonal, still spinning at the same rate. The physics of why a jet stream forms a hexagon rather than a circle has been partially replicated in laboratory experiments using rotating tanks of fluid. When a fast inner current is surrounded by a slower outer fluid, geometric shapes can emerge spontaneously. But why this one is so stable, so sharp-edged, so precisely maintained over decades, that question does not have a complete answer. Below that hexagon, Saturn's atmosphere descends with no solid surface to stop it. The pressure simply builds. At a certain depth, hydrogen, a gas we breathe harmlessly on Earth, becomes a liquid. Deeper still, it becomes liquid metallic hydrogen, conducting electricity like a wire, generating the magnetic field that surrounds the planet. Think of it this way. The entire planet is, in effect, a living electrical generator, 60,000 kilometers across, with no off switch and no moving parts you could ever touch. Scientists believe Saturn's core may be a dense, hot mixture of rock and metal at temperatures exceeding 11,000 degrees Celsius. Nothing has ever gone there. Nothing ever could. Any probe would be crushed and dissolved long before it reached bottom. The rings look eternal. They are not. Cassini measured a process called ring rain, a continuous drizzle of icy particles spiraling down Saturn's magnetic field lines and falling into the upper atmosphere at a rate of hundreds to nearly 3,000 kilograms per second. At that rate, the entire ring system will be gone within 100 to 300 million years. On a cosmic timescale, that is not long. The dinosaurs went extinct 66 million years ago. The rings, as we see them now, may not have existed when they were alive, and they may be even younger than that. Some models suggest the rings formed only 10 to 100 million years ago, possibly from the collision or tidal disruption of a moon that wandered too close. Saturn's gravity tore it apart, and the debris spread into a disk that we now call the most iconic feature in the solar system. We may be living in the brief window during which Saturn looks like Saturn. Separately, and entirely unexpectedly, Cassini found something that had nothing to do with the rings or the storms. In 2005, it flew close to Enceladus, a moon of Saturn barely 500 kilometers across, so small it should be frozen solid, and detected geysers, not small ones, jets of water vapor and ice particles erupting from the moon's south pole, shooting material hundreds of kilometers into space, with some plume components reaching nearly 500 kilometers and feeding Saturn's outermost ring directly. The plumes contained water vapor, carbon dioxide, methane, molecular hydrogen, and complex organic compounds. Beneath Enceladus's icy crust lies a global saltwater ocean, confirmed by Cassini's gravity measurements in 2014, with its global extent established in 2015. Hydrothermal vents on its seafloor appear to be driving the geysers. The conditions are, by any measure we know how to apply, potentially compatible with microbial life. Enceladus is not a dead, frozen moon. It is an active, warm, chemically rich ocean world hiding under 6 kilometers of ice in orbit around a planet we spent centuries calling beautiful and serene. None of this confirms life exists on Enceladus. The organic compounds could be abiotic. The hydrothermal activity could be insufficient to sustain biology. Scientists are careful, and the careful position is, we do not know. But here is what we do know. Of all the places in the solar system beyond Earth where the conditions for life as we understand it are present, Enceladus is near the top of that list. And it is orbiting a planet most people think of as a postcard. On September 15, 2017, the Cassini spacecraft ended its mission the only way NASA considered safe. We spent 400 years calling it the ringed planet, as though the rings were the point. They were never the point. The most terrifying thing about Saturn is not what it destroys. It is what it might be hiding,